Good morning, dear students. We will have a discussion on magnetic field concepts, that is moving charges and magnetic field. Let me have a small discussion. So as I said, moving charges, the title itself will give you a clear picture. Moving charges. Charges at rest gives rise to electric field. When charges move, we associate the word current. Rate of flow of charges. When charges moves with respect to time, means they are in motion. The moving charges will give rise to magnetic field. Do remember that. Moving charges give rise to magnetic field. What is a magnetic field? Like electric field, magnetic field is a measurable quantity. It has magnitude and it has direction. It's a vector quantity. And this magnetic field depends on position as well as time. Means it's a quantity which depends on time and which depends on space. Hence, I can write magnetic field notation is B. Magnetic field depends on position and time. But in this chapter, we restrict ourselves to magnetic field with respect to position, whereas variation with respect to time is given up. In this chapter, we'll talk about a magnetic field which is position dependent. The time dependent magnetic field we will not discuss. It is called time varying magnetic field. What I made a statement, moving charges gives rise to magnetic field, or current in a wire gives rise to magnetic field. What is a magnetic field? Magnetic field is a measurable physical quantity. You cannot see it, but you can sense it. Its influence can be detected with help of magnetic needle, compass needle. How to detect it? Oersted was the first person, long back around 1820, 200 years back. He did a small experiment. He observed. Take for example, this chalk holder is a wire. So current moves from, current enters at the bottom part, it comes out. This is called, it is, when you look at the wire, when you look at the current seems it is approaching you. It is called current enters at the bottom, it comes on the top. Means it is flowing in this way, the wire. There are two ways. The current enters at the bottom, it comes on the top, or current enters from the top, it comes down. Now, if I imagine a plane, this wire is in the plane, means this wire is perpendicular to the plane, means my hand will act as a plane. If this is a plane, if I hold this wire perpendicular plane, this is called, this plane is perpendicular to the wire. Now, if current is flowing in the wire, two ways, it enters, it comes out. Then whenever current moves in a wire, it gives rise to magnetic field. That magnetic field is circular in nature. And those circular magnetic field will be in this plane. It is called magnetic field are present in the plane where the magnetic field is normal to the current carrying wire. That's a statement. Let me have a small diagram, how it looks. Take for example, this is a wire and current starts from bottom and it is going out. And you observe from here, your eyes are here. What you will say, how to show it? We show it as a dot. Now, if you have a wire, current is downwards, you have an eye. It looks, with respect to this, it looks it is coming towards you. If current is moving away from you, so your eye is here, it looks if it is going away from you, again current, the convention is across. What is dot? Dot is a symbol which represents flow of current. Flow of current towards you, towards observer, I can say. Current, or we say magnetic field. Later I will support magnetic field also. Notation, magnetic field. Dot. Whenever I say dot, what is that? Think you have a notebook in your hand. The wire is perpendicular to the notebook and current is coming towards you, means current enters at the bottom, it comes from the top, and you look at it. When you look at it, current is moving towards you. When it is moving towards you, a dot. If it is moving away from you, it is a cross symbol. That's why cross indicates your eye with respect to an observer eye. It is called cross. Cross means moving away. This cross indicates either it corresponds to a current moving away or a magnetic field. B or I, the notations. What are the dot? Dot is a symbol. It represents, you have a plane. With respect to a plane, you have a wire. Through wire, current is flowing. And if current is towards you, there are two. When you have a wire, there are two. Either current enters from the bottom, it comes from the top. And you look from the top, it looks current is approaching you. It is reaching you. That means current is towards you or magnetic field is towards you. Both we can use. The convention is applicable for both. I will clarify it later. Now, if current is entering from the top, going away, when you look at it, it reflects that current is moving away from you. When something is going away from you, a cross symbol. When something is approaching you towards an observer, it is taken as a dot. So both are systematically done. Now let me take this, the diagram. What is this? This is a current. And I have taken a magnetic field. Let me show you. Think, because of a current in a wire, we made a statement. If we have a wire, current is flowing in a wire. Because of a current in a wire, surrounding the wire, this is called surrounding the wire. If this is a wire, surrounding the wire, you have a magnetic field. Close to this wire, the strength of the magnetic field is more. As you move away from the wire, the strength of the magnetic field decreases. Radially outward, the strength of the magnetic field decreases. But all the magnetic fields are closed loops, because north, the magnetic field lines originates and the end at the south. In that way, what I say, magnetic field are circular in nature. They are loop. Their concentration is very high. The strength of the magnetic field is high here. As you move away, it goes on decreasing. To detect what is the direction of magnetic field is a vector quantity. I associate a compass needle. Now think, this is a magnetic field. This is a current in a wire, and this dotted line is a magnetic field. Now question arises, what is the direction of magnetic field? Now since it is a dot, it is coming towards you. You can say coming towards you anti-clockwise. So anti-clockwise means take a small needle like this. Anti-clockwise, north is here. Again, another needle, north is here. The shaded region is a north. The unshaded is south. I hope things are very clear. Still you have any doubt? You can ask me. This is north. North, south. I hope you got it. When you have a wire which is carrying current, this diagram, this is dot indicates, this circle indicates a wire, physical wire, a dot indicates the current is towards you. And if at all there is a magnetic field around this wire, what's the direction of the magnetic field? The direction of the magnetic field is detected by a needle that is called a compass needle. This is compass needle. And it will be an anti-clockwise rotation. If at all it is, if it is away from you, if the current, this is again a wire, if current is away from you, again you have a magnetic field. And you have a clockwise. This is north, south. Again, you have magnetic needle compass needle will detect the direction of magnetic field surrounding, yes, surrounding a wire which is carrying current away from you. Everything. This is current away. This is towards you, towards observer. This is away from observer. This is north or south. I hope I made it clear. There are two ways of showing a current. Whenever you have a wire, current, if it is towards you, it is called a dot, and the direction of magnetic field is anti-clockwise. And if the current is moving away from you, it is shown by a symbol cross, and the direction of magnetic field is clockwise. As I said, the sources of magnetic field are moving charges and a current. Let me continue the discussion. What is magnetic force? Magnetic force, you can put it in this fashion, F subscript M. So like electric field and electric force, we have a magnetic force, which is mathematically defined as Q V cross B. Now the question is why this formula is like charge. Charge is a scalar quantity. Do remember that. Charge. Force, it is a force, but M stands for magnetic force. Charge is a scalar quantity. This velocity of a charge, velocity of moving charge, what is this B? Yes, which is dependent on position, as I said. This is magnetic field. This is your magnetic field. Now, look at the beauty of this formula. What is a force? An influence sensed by a charge. Whenever charge is there, it has a property. So it gives rise to its own field that is called electric field. Think it is not exerting its influence. Think you have a charge. When this charge is subjected to an external field, that is magnetic field, that field is called B of R. If charge is rest, if charge is not moving, charge is rest, then this velocity becomes zero. Velocity of a moving charge. If this velocity is zero, this magnetic force is zero. If charge is rest, means velocity equal to zero. Even though the magnetic field is not zero, your magnetic force is going to be zero. Do remember that. What is the statement? You have a charge. When this charge is at rest, think there is a magnetic field. Now charge is here. This charge never experiences any magnetic force. This is a beautiful statement. I made it. What? You have a magnetic field. Think you have a bar magnet. It has a north pole. It has a south pole. A source of magnetic field. Or you have a wire. Current is flowing in it, either from lower part to top or from top to bottom. This wire is supporting some current. Because of a current, there is a magnetic field. Now bring a charge that is called a Q. When you bring this charge Q in the vicinity of the magnetic field, the charge experiences no influence, that is called no magnetic force, provided the charge is rest. If charge is moving, means this external charge, if this charge is moving, then it experiences a magnetic force. Hence, the statement magnetic force is zero if charge is at rest. Rest means velocity is zero, even though there is a magnetic field present. This is the most meaningful statement. Now, like electric field is given by, all are familiar, 1 upon 4 pi epsilon 0 Q by R square. You have this formula. Now we are interested in magnetic field, looking into this formula. What is B? B is a magnetic. Look at this formula. Force is measured in Newton. Charge is measured in Coulomb. Velocity is measured in meter per second. And magnetic field, I don't know. This I am interested. Now B is equivalent to, just put all on the left hand side. Newton per Coulomb, meter per second. This per second will come in the numerator. Hence, the unit becomes Newton second per Coulomb meter is the unit of magnetic field. And it is simplified form is called Tesla. Tesla was a scientist of a higher standard, like Faraday, Michael Faraday, a Coulomb. Like magnetic field, magnetic force is measured in Newton, charge is measured in Coulomb, velocity of a moving particle is measured in meter per second. Magnetic field, I don't know what is the unit of magnetic field. Magnetic field unit is Coulomb comes in the denominator, Newton per Coulomb, meter second, it becomes second, come numerator, it becomes Newton second per Coulomb meter. The product Newton second per Coulomb meter is taken together, the whole shortcut is Tesla. What is Tesla? Tesla is the unit which is a big unit compared to Gauss. Means magnetic field is measured in Tesla or Gauss, or the standard is Newton second per Coulomb meter. This is how we measure it.